So the best way of doing this will be doing it in parts. So first of all, we'll go. Calvin Johnson decided to go to Las Vegas. First of all, he plays a game that deals with a standard deck of cards. He can only win if he pulls a heart. What is the probability that the card will be a heart? So that's our first part. So it is so since there's 13, it's a standard deck. 13 number of hearts, number of cards 52, so it'll be 1/4, so it'll be 25% chance of winning. So that's first one done. So then we'll go to the second one. He then goes and tries a new game that deals with rolling 2 dice. He has to get 2 even numbers to win. What is the probability? The probability he will roll 2 even numbers on his first roll. So dice have 6 sides, so it's 6. So and there's 3 even. So there'll be 1/2, and we'll have to multiply them because there's 2 dice. So 1/2 to 1/2, it'll be 1/4. So 25% chance of him getting that. So we're done. We've done 2 parts so far. So since he wanted to try every game, he decided to try another card game. This game he had to pull 4 hearts in a row to win without replacement. What is the probability of getting 4 hearts in a row? So since there's no replacement, this will be so there's 13 hearts, so 13 52, so that's the first one, pulls it, so that's the chance of first try. Then there's 12 and 51, since you already took a card out and it's a heart, so 12 51, same with 11 50 and 10 over 49. So once you multiply them and divide, you'll get 0.00264 or 0.2264% chance of winning, of pulling 4 hearts and winning. So I've done 3 parts so far, so we'll go to the next one. He loses and goes to the next game. So a number from 1 through 10 is chosen at random. What is the probability of choosing a 1 or an even number? So this one, so there's 5 even numbers from 1 to 10. So it's 5 and the other numbers of 1. So chances 5 to 10, you'll get a even, and 1 to 10 you'll get a 1. So you add them because it's saying it's or. So 6 over 10, which is 60%, 0.6. Then we'll go to the next one, which is he then tries so he decides to try this one game again, but now he needs a number that is odd or a prime number. What is the probability of winning? So this will be kind of similar to the other one, but this one will actually have numbers that overlap each other, which are like repeated, are used twice. So there's 5 odd and there's 4 prime, but there's 4. No, there's 5 prime. But out of these 5, there's the odd ones are already used, which is 1 2 3 4. So there's 4 used, so we'll put 4 here, so it'll be minus 410 the total. So 5 prime numbers and 5 odd, so we'll end up getting 60% again for this one. I don't know why they're the same, but yeah. Then we'll go to the most complicated one, which is he then tries the hardest game, which is Twice the last game has to pull one of each 4 different symbol cards in a standard deck of cards to win. There are 13 hearts, 13 clovers, 13 spades, 13 diamonds. What is the probability that a hand will contain exactly one of each card? That's part A. So this is how you set it up. It'll be, since the R's have to equal the total amount, so 13, so hearts, and you want 1. 13 spades, you want 1. 13 clovers, you want 1. 13 diamonds, you want 1. And in the bottom, you'll put the total number of cards you're going to draw out, which is 4, which is the R, and the total number of cards, which is N, 52. So you end up with this. 28,561 over 270 whatever. You'll get 0.015 or 10.5%. Then part B is chance of pulling 4 hearts. This is a 4, sorry, 4 hearts. You'll have a, so you'll set it up kind of similar, but since you're gonna get 4 hearts, you'll put 13C4, and since the other ones they'll just equal 1. 13C0, they won't matter. Over 52C4, which is same, and you'll get